for example here, the first term in a sequence, we'll use the letter A to refer to that. So the first term could be called A sub 1. Again, it's a notation we use to identify what term number we're at in a sequence or a pattern. So A sub 1 would be the first term. Common difference means, that's the amount you add, right? So, or add or subtract, I guess you could say. But anyhow, it's positive force, we'll be adding. So let me do this now. First term is 6. If I add 4, 10, right? And then the objective here was to get the first 6 terms. So 6 plus 4 is 10, plus 4 is 14, plus 4 is 18, plus 4 is 22, and plus 4 more is 26. And again, look, 1, 2, 3, 4, 5, 6. So I have the first 6 terms of the sequence. So the terms are just the numbers in the sequence. Again, it may be called a series. It's also a pattern. All I had to do was add 4 each time. It tells me the first term and what to do to get the next one. Add 4. Here, if you look at the next one is giving me the first term. It's 5, and the common difference is -2, meaning add -2, aka subtract 2. So on this one, first term is 5. And I'm adding -2, again, subtracting 2, so 5 minus 2 is 3, minus 2 is 1, minus 2 is -1, minus 2 again is -3, and if I subtract 2 from that, I'm at -5, so let me just see, 1, 2, 3, 4, 5, I have the first 6 terms again. The objective was just to get the first 6 terms. We could keep going, and then as you can see just from here alone, like, this is the first term, second term, third term. This is the 6th term. All I did was subtract 2 each time to get the next term, and again, got all the way to the 6th term. So keep in mind, if you wanted like the 100th term, you might not want to subtract 100 times. So that's why there's a formula for that, as we'll get to in a minute. So you see, right, the first 6 terms of the arithmetic sequence. First term is 8. Common difference is subtract 3. So in this one, again, first 6 terms, first one's 8, subtract 3. Second term is 5, subtract 3. Again, 5 minus 3 is, positive 2. Mess that up. And I'm going to subtract 3 from that. 2 minus 3 is -1. -1 subtract 3 is -4. And -4 subtract 3 again is -7. So that's the first 6 terms on that one. It's important to understand what each of these, I guess we can call them inputs or variables are. We already talked about what some of these are, right? So I might be trying to find a, specific term, right? This, I guess we'll just call that the nth term. It says it here. We won't write that. Obviously, you'd be plugging in the first term for that. For A sub 1, you'd plug in the first term. N is the term number you're trying to find. For example, if I was trying to find the 50th term, then I write A sub 50 here, and then this number right here would be a 50. So term number is the N, and then D is the common difference, which you saw up top. The common difference is the number, the amount you're either adding or subtracting. So let's go ahead and look at one of these problems. So I'm trying to find the nth term, and n equals 8. So in this problem, I'm trying to find the 8th term in a sequence. So I can definitely start with A sub 8. Again, the 8th term, it tells me find the nth term, and then it says n is 8. So again, I'm finding the 8th term in this formula. I'm just going to refer back to this formula, guys. The first term goes here, right, A sub 1, and it tells me A sub 1 equals 4. So just plugging in what I need to. Again, I'm finding the 8th term, so here n is 8. Subtract 1 is part of the formula. Subtracting 1 is just part of the formula. And then multiply by the common difference. In this problem, the common difference is -7. So don't just write it like that, because I'm supposed to be multiplying by that. So better put that in parentheses, or I'll think I'm subtracting. Anyhow, what's I going to say here? Well, let's go ahead and do the calculation on this, right? So, that's right. So instead of subtracting 7, right, right? To get the 8th term, I might have to subtract 7 8 times, but this formula allows me to just get the 8th term outright without having to make that list like we did up here. So here goes finding the 8th term. 4 times 8 minus 1 is 7, and then 7 times negative 7. Oh, whoops, forgot my plus sign, guys. There's a plus sign here. That is going to mess everything up if I don't do that. So you get to watch me make a mistake or catch a mistake. So don't forget that plus sign. So it's 4 plus, right? I already subtracted. 7 times negative 7 is negative 49. And 4 plus negative 49 is aka negative 49 plus 4. 4 is positive, 49 is negative. That is subtraction, so it's 45, but it stays negative because negative 49, right? It has a greater absolute value. So this is your 8th term, right? Your 8th term in this sequence would be negative 45. If you subtracted 7 8 times, right? If you started out with 4 and subtracted 7 8 times, you'd end up at negative 45. But this is a way to get the 8th term or any number term, right? Use the formula without having to add or subtract a certain number of times. So here, I want the 24th term, right? It says n is 24 right there, so I know that I want the 24th term. Again, following my formula, a sub 1 would be the first thing I plug in, right? Negative 52 plus, don't forget the plus sign like I did last time, n minus 1 is going to be 24. Again, just using the formula, guys, just plugging it in, times the common difference. In this case, it's a positive 17. So in this problem, let's break down that negative 52 plus 24 minus 1 is 23, and then 23 times 17. So have a calculator handy. 23 times 17 is 391. So negative 52 plus 391. Just calculate that. 339 here. So 339 is the 24th term. And again, the whole point is, if you go back to the first couple problems, you're literally adding or subtracting some amount to get the next term. And you can eventually get to the 24th term by continually, like in this one, we could have continually added 17 24 times to eventually get to 339. But again, the formula gives us a way to get to any numbered term without having to add or subtract a bunch of times. So just keep that in mind. If you want a certain term, like the 8th or the 24th or the 50th, the formula works. If a problem asks you list the first 6 terms, then you just would add or subtract 6 times like we did in those problems at the top. So I just copied down the formula already, guys, so I don't have to memorize it. Again, I can just refer to it by copying it down. As I read through this problem, I'm pointing out my variables. Find the 9th term, n equals 9. I know that off the bat. In an arithmetic sequence whose first term is 6, so since the first term is 6, remember a sub 1 equals 6. Common difference is negative 5, so d is negative 5. And then again, don't forget what arithmetic sequence is, because we'll get into geometric eventually. Remember, arithmetic sequence means a pattern or series or sequence achieved by just adding or subtracting the same amount. So I want the 9th term. Remember, n is 9, so I want the 9th term. A sub 1 is 6. Plug that in. Again, n is 9. Use that in the beginning and then here, and then the common difference is negative 5. So you can just calculate right after you plug in. You can just calculate 6 plus 9 minus 1 is 8. 8 times negative 5, right? So 6 plus negative 40. And then final answer here, negative 34. So this next one's testing our ability to not just use the formula, but actually simplify it a little bit. So I already wrote a few things down here, guys. It says in 1990, teachers earned approximately $30,532, and that amount has increased every year by about 1,472. So basically, teachers earned this much in 1990. If you add the difference, what it's going up by, little over 32,091, add 1472 again, and it's about 33,476 in 1992. So anyhow, they want us to write a formula. So remember, the formula is, if you want the nth term, right, a sub n, and you plug in a sub 1 here, right, so 3532 plus, that's n minus 1 times the common difference. In this problem, the common difference is the 1472 it's going up by, right? Teacher salary is going up by 1472 every year, and they want us to simplify, or I'm asking you guys to simplify this formula. So 3532 plus, right, if you distribute here, you get 1472 n minus 1472, and then you can simplify that because you have these like terms here, right? 30,532 minus 1472, so you should end up at 29,060, right? You still have 1472 n, and then plus again, that's going to be, if you combine 3532 minus 1472, $29,060. So that's your formula. You got to figure out what a sub 1 is and what d is, right? You got to identify them at least, and then you can distribute and combine like terms to simplify. So we can use this formula here to figure out what teachers made in any year now. But remember, n represents the number of years after 1989. So look at this next one. Based on this rule we just came up with, how much do teachers have earned by the year 2010? So remember, n equals number of years after 1989. So whoops, not 88, 89. So if you just subtract, right, we want to know about 2010. How many years has it been since 1989? All we got to do is subtract, and n equals, that's going to be 21 years. So n is 21. Now I can use this formula, right, to get the 21st year, or 21st term in the sequence. 1472 times 21 plus 29060, and then you should get a final answer on this one that in 2010 teachers made about $59,972. Again, I just use a calculator, right? Multiply, then add. So this next problem, I already identified a couple things here. It's the price of a home in 1995. So the price of a home in 1995, $159,000 is a sub 1. The price increases every year. It says by about 9,700. So it's increasing by, again, that amount. That amount is your difference in the formula, common difference. And I plug those into the formula, guys. If I want the nth term, right, on any particular term, I can take 159,000 and then add, multiply n minus 1 by 9,700. Remember, if you do that without knowing what n is, you can still simplify this, right? You get 9,700 times n is 9,700 n. 9,700 times negative 1 is minus 9,700. And again, like the last one, if you combine like terms, you get, well, let's bring the 9,700 n down, but down if you use a calculator or do it by hand, 149,300 would be your simplified formula, right? Well, all we do is plug in the numbers we know and we simplify the formula, and we can use that to figure out how much a home will cost in any given year, like 2010. So remember, it's years after 1994 in this case. So in this case, 2010 minus 1994 will give us the number of years we need, right? So that's n is 16 years. Now that I know n is 16 years, I'll just take that formula that I had to come up with, right, and figure out that 16 years later, right, 9,700 times n is 16 plus the 149,300, and so if you go ahead and multiply here, you get 155,200, and then if you add that to the first term, right, 149,300, you get $304,500 for the average cost of a one-family home. Oh, dang it, guys, sorry about that. Good.